So for this problem, we have a 1,000 kilogram car moving eastward at 20 meters per second. So before our collision, we have a car that is 1,000 kilograms moving eastward at 20 meters per second. It's going to collide inelastically with a 1,500 kilogram van moving north at 30 meters per second. So this van is moving 30 meters per second north, and it weighs 1,500 kilograms. So we want to know what is the velocity after the two vehicles immediately after the collision. So before, we have one moving east and one moving north. After, we expect these cars to stick together because it's an inelastic collision and move northeast. Their total mass is 2,500 kilograms, and its velocity is what we're solving for because that's our unknown. So we now need to define our coordinate system. So we're going to define east and west as x, so east is positive x, and north and south as y. So our truck is moving north, so that's positive y, and our car is moving east, which is positive x. So afterwards, we have to keep the same coordinate system. Our car-truck amalgamation is going to be going right, so positive x, and up positive y. So it has a x and y component. We've assigned our mass and velocity to each object before and after the collision. The car has 1,000 kilograms. It's going 20 meters per second. The truck is 1,500 kilograms. It's going 30 meters per second. And the stuff crashed together is 2,500 kilograms, and it is going at unknown velocity. So now we need to break down our velocities into the respective components. So x and y before. So x before, our car is one. So our car has, we'll call object A, and our truck we'll call object B. So A has an x component. Here, I'm going to erase this for more room. A has velocity on 20 meters per second and a mass of 1,000 kilograms. So its momentum in the x direction is 20 times 1,000, or 20,000. Car B is moving in the x direction 0 meters per second, 1,500 kilograms. So its momentum before in the x direction is 0 because it's only going north. In the y direction, car A is going 0 meters per second. It's only moving east and west. And car B is moving 30 meters per second, and it has a mass of 1,500 kilograms. So its total momentum in the y direction is 30 times 1,500, which is 45,000. So we have 20,000 and 0, and 0 and 45,000. So our initial momentum, PIX, is equal to 20,000. Because we just sum 20,000 plus 0, and we get 20,000. Our PIY is equal to 0 plus 45,000, or 45,000. So we know our initial momentum in both directions. Next, we need to find the total momentum of the system in every direction after the collision. So let's move down here. We know that P final x is an unknown because we don't know the velocity. But that is equal to 2,500, that's the total mass of those things, times VFX. And PFY is also an unknown, but we know the mass, 2,500, and our unknown is VFY. So using the law of conservation of momentum, we can set initial equal to final. Momentum in both directions. So in the x direction, we get the initial is 20,000. Our final is 2,500 times VFX. So that means VFX is 20,000 divided by 2,500, which is 8 meters per second. If we go to the y direction, P initial y is 45,000. P final y is 2,500 times V final y, which means that 45,000 divided by 2,500 is equal to V final y. So V final y is equal to 18 meters per second. So we've done our algebra to find the x and y components of our velocity, but we need to now use the Pythagorean theorem and SOHCAHTOA to find the velocity's magnitude and direction. So what we have here now is that we have our x direction of our final velocity is 8 meters per second, and our y direction is 18 meters per second. So that means V final, which is our unknown we're trying to solve for, is the hypotenuse of that triangle, and our theta, our angle of ours from north of east, is this theta here. So, using the Pythagorean theorem, VF squared is equal to VFX squared plus VFY squared. So VF squared is equal to 8 squared plus 18 squared. And that is equal to 64 plus 324. VF squared. VF squared is equal to 388. So VF is equal to the square root of 388, which is 19.7 meters per second. So our final velocity is 19.7 meters per second. But in what direction? We now have to use SOHCAHTOA. So this is our opposite, and this is our adjacent. So that means that tangent of theta is equal to O over A. That's 18 over 8. 18 over 8 is 2.25. So tangent of theta is equal to 2.25. So theta is equal to tangent to the minus 1, or arctan, of 2.25, which in degrees is 66 degrees north of east. And that is our velocity, 19.7 meters per second, 66 degrees north of east.